Okay, next is B-tree deletion case. Okay, B-tree deletion. Okay, so in the B-tree deletion also, there are different cases we want to consider. Okay, so first case, case one is if the key is a leaf node. Okay, this is the first case. Okay, there are two cases basically. Case one is if the key is in the leaf node. Key is in the leaf node. Okay, so that is case one. And case two is if the key is in the internal node. Basically, there are two cases. If you want to delete a key, then you should check these two at first. Sometimes the key will be in the leaf node. Okay, else it will be in the internal node. So this is case one. Case one is it is in the leaf node. Okay, so next the case one is again divided in this way. Okay, case 1.a. Okay, case one means what is case one? It is in the leaf node. Key to be deleted in the leaf node. Then the first case is case 1a, then case 1b. Okay, case 1a, case 1b. What is case 1a? Leaf node contains more than the, note this. Okay, leaf node contains more than the minimum number of keys. So the minimum number of keys allowed in a leaf node in the node is m by 2 minus 1. M is the order and floor function is used. Okay, floor function is used. Anyway, first we will check leaf node contains whether the leaf node contains more than the minimum number of keys. In this case, we simply delete it. Okay, this is the first case. This is the first case, case 1a. Okay, case 1a. We can go to an example. Okay, for example, suppose this is the case. Okay, so suppose this is a binary BT and the order is m is equal to 5. Okay, so minimum number of keys in a node allowed is what? M by 2 minus 1. Okay, so minimum at least, okay, these much keys are needed. Minimum number of keys in a node is floor of m by 2 minus 1. In this case, which is equal to 5 by 2, 2.5, it is floored to 3 and 3 minus 1, it is 2. Okay. In this case, m is equal to 5. So the minimum number of keys in a node should be 2. Okay. And the maximum number of keys is m minus 1. Maximum number of keys allowed in a node is m minus 1. Just note this property. And in this case, we want to delete 15. Okay, we want to delete 15. Where 15 is? 15 is here. Okay, 15 is here. Okay, so it is in a which type of node? It is in a leaf node. Okay, it is in a leaf node. Then how many keys are in this node? How many keys are in this node? 3 keys are there. So this leaf node contains more than the minimum number of keys. Okay, the leaf node contains more than the minimum number of keys. Basically, 2 is the minimum number of keys in this B tree. But if you consider this leaf node, it contains more than minimum number of keys, 3 keys. In that case, we can apply which rule? We can apply case 1.a. What is case 1.a? just simply delete it. So 15 is deleted and it comes like this. Okay. This is the simplest case. Okay. So that is case 1a. Okay, I given name in this way. Okay, case 1 is the keys in the leaf node. Then case 1.a is leaf node contain enough number of keys, or key node contains more, leaf node contains more than the minimum number of keys. Means 4 of m by 2 minus 1. More, if more than this number of keys, then we can simply delete it. Okay, just remember that. Okay. Next is case 1.b. Okay, it's another case. So the keys in the leaf node. Case 1 means it is in the leaf node. Okay, so case 1 means it is in the leaf. Okay, so again, second case is case 1.b. Okay, so what is case 1.b? Leaf node contains the minimum number of keys only. Okay, leaf node contains the minimum number of keys only. Okay, leaf node contains the minimum number of keys only. Okay, so in this case, for example, this is the minimum number of keys allowed in a node. If the leaf node contain exactly or below that, okay, or exactly or below this number, then in this case, if we delete the key, then it violates the B tree property. Okay, so the leaf node contains the minimum number of keys, and if we performed a deletion, then surely it will violate the B tree property. How can handle it? There are three cases we need to consider. One case is borrow from the immediate left sibling node. This is the first case. So basically, this is case 1.b, and in that one case is borrow from the immediate left sibling node if possible. Okay. First try this one. If it is success, no problem. If it is possible, no problem, we can do it. Sometimes it will not be possible. At that time, what we want to do? We want to try this one. If it is not possible, then try this one. Second case, borrow from the immediate right sibling if possible. This is the second case. If it is not possible, then we will move to the third case. Borrow from left or right siblings. Okay, if not possible, this is the third case, not possible to borrow from the left or right sibling. Then we need to handle these three cases. Okay, so next we are going to discuss that cases. Okay, for example, I want to delete 16. Okay, I want to delete 16. Where is 16? Where is 16 actually? Just write it. Where is 16? 16 is here. Okay, 16 is here. Then check it is a leaf node. Okay, but it contains how many keys in this node? 2. Okay, so it contains exactly m by 2 minus 1 keys. So we should apply other cases. We should apply case 1.b. Okay, case 1.b, and in the case 1.b, there are three methods. One is borrow from immediate left. Second is borrow from immediate right. If these two cases are failed, then we should apply the case 3. Okay, let us check. Next, so this is the case. Try to borrow from the right sibling. Is it possible? Try to borrow it from the right sibling. Is it possible? The right sibling, this is the right sibling of this node. I want to delete 16 and this is the right sibling. But if I borrowed one key, then this node also violate the B tree property. Okay, try to understand this concept. If I borrowed one key from the right sibling, then what will happen? This node, this leaf node violate the B tree property. So it is not possible. So try to borrow from left sibling. Is it possible? Is it possible? There are 3 keys. Okay, there are 3 keys. Here only 2 keys. Yes, it is possible. Okay, I can borrow one key from this left sibling. Okay, left sibling, and okay, so we are applying this case. Borrow from immediate left sibling. Borrow from immediate left sibling. So how it will be borrowed? So we need to apply this case. Borrow from immediate left sibling. So in that case, first we need to find the largest key from the left sibling. Which is the largest key in the left sibling? Which is the largest key in the left sibling? Which is the largest key in the left sibling? It is 6. Okay, 6 is the largest key. So find out the largest key in the left sibling. Okay, if it is in the left, if we are borrowing from the left sibling, then we should find the largest key in the left sibling. Then move it to the parent node. So what will happen? Move it to the parent node. That is 6 is moved to the parent node. Who is the parent node here? Here 6 is moved to its parent key node. Its parent key. Okay. So 10 is the parent. Basically, you can check it. I am trying to borrow from here or this node. So this is the parent key node. So what I want to do is that find the largest key 6 and move it to the parent. Now this becomes 6. Okay, this becomes 6. Then 10 is moved to where? 10 is moved to this node. Okay, 10 is moved to this node. That is here parent key moved to leaf node. Okay, parent key is moved to leaf node. So you can check it. 6 comes here and 10 comes here. Okay. We want to delete 16. 16 is deleted from the leaf. So 10 and 14 remains here. Okay. This is borrow from immediate left sibling case. Borrow from immediate left sibling case. So try to understand the procedure. Okay, suppose you want to borrow from the left sibling, then find the largest key. Then move the largest key to the parent node, parent key node. Then move the parent to the leaf node. Okay, this procedure we want to apply. Okay, this is case 1.b. Okay. Similarly, suppose you are borrowing from the right sibling, then what will be the procedure? Suppose you are borrowing from the right sibling, then what will be the procedure? Question ചോദിക്കാം. ഒരാൾ പറയോ? ആർക്കെങ്കിലും അറിയോ? മസ്ന ഒന്ന് പറഞ്ഞു. ഓക്കെ, അതായത് റൈറ്റ് സബ്ലിങ് എന്നാണെങ്കിൽ മിനിമം എലമെന്റ് കണ്ടുപിടിക്കണം. അതിനടുത്ത് എങ്ങോട്ട് മൂവ് ചെയ്യിക്കുക? പാരന്റിലോട്ട് മൂവ് ചെയ്യിക്കുക. എന്നിട്ട് പാരന്റിനടുത്ത് എങ്ങോട്ട് മൂവ് ചെയ്യിക്കുക? ലീഫ് നോഡിലോട്ട് മൂവ് ചെയ്യിക്കുക. എന്നിട്ട് എന്ത് ചെയ്യാം? ലീഫ് നോഡിന് കീ ഡിലീറ്റ് ചെയ്യാം. ഓക്കെ ഓക്കെ, അപ്പൊ ദിസ് ഇസ് ദ കൺസെപ്റ്റ്. Okay, so this is second case, case 1.b case. Okay, so the resulting tree comes like this. So this is the resulting tree, and here I am concentrating on this portion only. This is a big tree. I am concentrating on this area. There would be some other nodes will be there. I didn't return it here. Okay, just I'm focusing in this area. Okay, so that's why I written a line in here. Okay. Okay. Okay, this is the case. Next we are moving to another situation. Okay, so from this tree I want to delete 14. Okay, just note it. What I want to delete is that I want to delete 14. Okay, so where is 14? 14 is in the leaf node. Okay, so 14 is in the leaf node. Then check, is it possible? How many number of keys in this node? 2. So we can't delete 14 directly. So try to get it from the right sibling. Is it possible? No, because this also 2. Try to get it from the left. It is also not possible. It is also 2. Then what we will do? Okay, that is the third case. If the first 2 cases are failed, then we need to apply the third case. We need to merge. Okay, we need to perform merge operation. Let us go to an next to understand the concept. So this is basically delete 14 is basically we need to apply case 1.b. Okay, case 1 is leaf, point B is second case. Okay, next, unable to borrow from left or right sibling. Oh, this is the problem. Okay, that is both not having more than the minimum number of keys. Okay, how can handle it? Oh, this is the procedure. Merge with left or right sibling. Merge with the left or right sibling. Okay, either I can merge with the left sibling or right sibling. Include parent of the sibling and leaf node in it. Then delete the key and rearrange the pointers. So this is the procedure I want to apply. So what will happen here? This is the result after applying this. What we have done is that, so I merged with the left sibling. I merged with the left sibling. So I'll show it here. I will merge with the left sibling. This node is merged with the left sibling. So which are the keys? 4, 5, also 6. Note it. 10, 14. 10, 14. What is 6 actually? 6 is the parent of this node. This is included in it. Okay. Then I want to delete which node? Then I want to delete which node? I want to delete 14. I just deleted this. I just deleted this node. Okay. So this is the result after performing merge. 4, 5, 6, 10. Okay. Then rearrange the pointer suitably. So you can check here. 4, 5, 6, 10 will come. And now 6 is gone from here, so only one key is 20. So 20 is, you can check here. Okay, 6 and 20, 6 is merged in this way. 4, 5, 6, 10. So only one key is there. Okay, one key is there. I performed this operation. Okay, I performed the basic operation, but the problem is after performing the operation, what happened? This is still violates the B tree property. Okay, I performed the operation. Okay, but the problem is after performing this still violates the property. Why? Because only one node. Okay, only one key. Okay, so this minimum 2 keys are needed. Okay, so we need to handle this case also. So we performed the operation. Third case we handled, but the resulting tree violate the property. Then what we will do? Okay, here I given the explanation, but here 20 violates a B tree property. Then it asks for key from right sibling. Okay, then the procedure is this: if a B tree violates the property, then this node 20 ask to split. Okay, whether can you give a key to me? Okay, this is the procedure. Okay, can you give a key to me? But here only 2 keys. Okay, if I given a key, then this also violate the property. Then he will ask to the parent, can you give a key to me? Yes, it is possible. Why? Because it is a root. Root, in the case of a root, one key node is allowed. So that is the concept. Okay, but here 20 violates a B tree property, then it asks for a key from right sibling 70, 72, but it's not having more than the minimum number of keys. Then it asks for a key from its parent. Since it is a root, it will give one key, 50. So this is the resulting. This only 80. 50 is given to, not 50, it is 50. Okay. Okay, then one key is given, which is 50. 50 is given to him. Okay, 50 comes here, and 50 is given. Okay, I have some doubt in this case. Anyway, this is the procedure from the, I asked from the right sibling. Then I ask a root. Then root will come here. Okay, root will come here. Then 20, 50 will come here. And 80 will comes here. Okay. is here, and there is some corrections needed, I think. Okay. Anyway, we can discuss that case in the next class. This is case 1, and the second case is case 2. Okay, case 2 means he is an internal node. Okay, we will discuss it in the next class. In this case, okay, some errors in this area. Okay. Next, the case 2. Case 2 means key in internal node. Okay, if the key is in the internal node, what we want to do? Then we want to apply these cases. Case 2.a, this is case 2, and I want to apply case 2.a. If case 2.a is not a success, then I want to apply case 2.b. If it's not a success, I want to apply case 2.c. This is the procedure. So what is the case 2? What is case 2? Key is in an internal node. Okay, so I want to do this procedure at first. Find the in-order predecessor. Okay, this is very important. Find the in-order predecessor of that node. If node having the in-order successor having more than the minimum number of keys, then target key is replaced with the in-order predecessor. Else check in-order successor. So then go to here. So in this case, I'm taking an example. For example, delete 95. I want to delete this. So I want to apply which case? Delete 95. Okay. So first I want to here the in-order predecessor. What is the in-order predecessor? How can find the in-order predecessor? It is the largest key in the left child of that node. Largest key in the left subtree of largest key in the left subtree of that node, that key. Okay, so in this case, in order predecessor D3. But the problem is it is only having 2. So I can't take it from here. Then what I want to do? So we check in order successor. Who is the in order successor of 95? This I want to delete. Okay, it is 100. Okay, so what I want to do?